Imagine this. You leave Earth, float into space, and within seconds, you find yourself in another galaxy. You didn't break the speed of light. You didn't spend decades traveling. You just took a shortcut. Science fiction? Maybe. But in theoretical physics, that shortcut might actually have a name. A wormhole. Wormholes have captured the imagination of physicists and dreamers alike for nearly a century. But what if they were more than mathematical curiosities? What if we could really use one? Could we travel unimaginable distances in the blink of an eye? Could we explore galaxies that would otherwise take us lifetimes to reach? Today on Cosmic Clarity, we're diving into the question, what happens if we travel through a wormhole? The answers are strange, thrilling, and maybe even terrifying. Let's begin. Let's clear one thing up. A wormhole isn't a hole made by worms in the fabric of reality, though that would be cool too. A wormhole is a hypothetical tunnel through the fabric of space and time, a shortcut that connects two distant points in the universe. Think of space as a giant sheet. If you want to get from one side to the other, you'd normally travel across it. But if you could fold that sheet and make the 2 points touch, you could punch a hole right through and skip the distance. That's the basic idea. Mathematically, wormholes are allowed by Einstein's general theory of relativity. Back in 1935, Albert Einstein and Nathan Rosen proposed what's now known as an Einstein-Rosen bridge, a structure that could connect two black holes or two different points in space-time. So yeah, wormholes aren't just science fiction, they're science possibilities. But how real are they? Here's where things get complicated. We haven't found a wormhole, not yet, but the equations of general relativity say they could exist. In theory, the universe might naturally allow them to form, perhaps in the early moments after the Big Bang, or deep inside black holes. The problem? They're unstable. In their natural state, wormholes would collapse almost instantly, long before anything could travel through them. So what could keep them open? Enter exotic matter. This isn't your everyday matter made of atoms. Exotic matter would have negative energy density. It would repel instead of attract. It's a bizarre concept, but not entirely fictional. Quantum physics gives us hints that such stuff might be possible through things like the Casimir effect. If we could find, or create, enough exotic matter, we might be able to stabilize a wormhole. Emphasis on might. Okay, let's dream a little. Let's say we've done the impossible. We've stabilized a wormhole and opened it wide enough for a spacecraft or a person to pass through. What would happen if you walked in? Surprisingly, it might not feel like anything. No fire, no sudden flash, no gravity shifts. If the wormhole is smooth and well-behaved, you could step through just like walking from one room to another. And then, you'd be somewhere else. Maybe on the far side of the galaxy, maybe near a distant quasar, maybe orbiting a completely alien star system, all in seconds. To you, the trip would feel instant, but to someone watching from the outside, you just disappeared and reappeared light years away. You didn't travel faster than light, you just skipped the distance. And now things get even weirder. Because if wormholes connect not just points in space, but also in time, then you're looking at a potential time machine. Yes, seriously. A wormhole that's been moved at near light speed, then brought back to its original location, could create a time difference between the two ends. This means you could, in theory, enter the wormhole and exit before you entered. That's not just strange, it's paradoxical. You've heard of the grandfather paradox, right? What if you go back in time and prevent yourself from entering the wormhole in the first place? That's what physicists call a causality violation, and it's one of the biggest headaches in theoretical physics. Some believe that nature has built-in safeguards to prevent these paradoxes. Others think wormholes might simply be too unstable to allow such travel in the first place. Still, the math says it's possible. And that's enough to keep the debate alive. Even if we could open and stabilize a wormhole, traveling through one would be dangerous. First, there's tidal forces. Just like falling into a black hole, you might get stretched, spaghettified by gravitational differences across your body. Then there's radiation. A wormhole could act like a cosmic lens, concentrating energy from all directions. One burst of gamma radiation could cook your spacecraft. And finally, instability. A wormhole might look calm and stable until it's not. A tiny fluctuation could cause it to collapse mid-transit, turning your shortcut into a very expensive grave. So while it's tempting to dream of instant space travel, wormholes are not exactly tourist-friendly. Movies love wormholes, and who can blame them? They're the ultimate science fiction plot device. In Interstellar, a wormhole near Saturn allows humans to search for a new home across the galaxy. In Contact, it connects Earth with alien intelligence. And in Stargate, wormholes are literally used like subway stations. What's interesting is that many of these depictions are based on real science. Physicist Kip Thorne, who advised Interstellar, even developed new equations to model how a wormhole would look. Of course, Hollywood takes liberties, but the core idea that wormholes are shortcuts through space-time is rooted in legitimate physics, and that makes them one of the few sci-fi ideas that could someday become science fact. Right now, wormhole travel is impossible. We don't know how to find them, build them, or stabilize them. But if you had said a century ago that we'd split atoms, land on the moon, or image a black hole, people would have laughed. Theoretical physics is constantly evolving. String theory, quantum gravity, and other emerging fields may one day give us tools to understand and manipulate space-time itself. Some scientists believe that microscopic wormholes might exist at the quantum level, popping in and out of existence. Could we one day scale them up or create them from scratch? It's a long shot, but the fact that it's not ruled out keeps the dream alive. Because if we could use wormholes, the universe would shrink. No more light years, no more generational ships, just pure, instant cosmic travel. Wormholes challenge everything we think we know about the universe. Space, time, distance, they all break down at the wormhole's edge. Even if we never travel through one, the mere idea pushes science forward. It makes us ask bigger questions, design better theories, and imagine possibilities far beyond our current reach. That's the power of theoretical physics. It doesn't just describe the universe, it dares us to imagine what's possible within it. So what happens if we travel through a wormhole? We might arrive somewhere wondrous, or dangerous, or completely unknown. But one thing's certain, we'll never look at space the same way again. Let's stretch our imagination even further. What if wormholes don't just connect points in space and time, but completely different universes? Yep, you heard that right. Some of the most mind-blowing theories in modern physics suggest that wormholes might actually be gateways to parallel realities, entire other universes with their own versions of physics, history, and maybe even you. This idea comes from a blend of string theory, quantum mechanics, and the ever-popular many worlds interpretation. In that interpretation, every quantum decision spawns a new branch of reality. So, theoretically, there are infinite versions of the universe. One where you watched this video, one where you didn't, and one where you're the one explaining wormholes on a channel called Cosmic Clarity. If wormholes can connect not just points within our universe, but between universes, they wouldn't just be shortcuts. They'd be interdimensional portals. Think about that. You could step through a wormhole and end up in a universe where the laws of gravity are slightly different, or where Earth never formed, or where dinosaurs never went extinct, and maybe even evolved into intelligent life. It's like science fiction turned up to 11. But is there any science behind it? Actually, yes, sort of. Physicists like Kip Thorne and Michio Kaku have explored whether wormholes might be open at both ends to different quantum realities. Some versions of M-theory, an extension of string theory, allow for higher dimensional branes, entire universes stacked like pages in a book. If a wormhole could pierce through one of these brains, it might take you out of our cosmic story and into someone else's. The real question is, would you survive the transition? Probably not without serious protection. Different universes could have different values for fundamental constants, like the speed of light or the charge of the electron. Even a slight change could make atoms fall apart or prevent molecules from forming. The rules that make life possible here might not apply there. But here's the kicker. We might not have to physically travel to other universes to learn about them. Some theories suggest that wormholes could allow information to pass between universes. Imagine scientists communicating with counterparts in alternate realities. It sounds like fantasy, but in the quantum world, particles can be entangled across distances, and maybe even across dimensions. In fact, there's a bold idea floating around in theoretical physics known as ER equals EPR. It proposes that entangled particles' EPR pairs might be connected through tiny wormholes' ER bridges. If true, this could be a hidden framework tying together not just space and time, but reality itself. And if that doesn't bake your noodle, let's take it one step further. Could wormholes be the reason we don't see other universes? Maybe they're not out there. They're next door, only accessible through extreme space-time distortions. Maybe the Big Bang wasn't the beginning of everything, just the birth of our bubble in a much bigger cosmic foam. In this view, wormholes aren't sci-fi portals. They're threads connecting a cosmic multiverse quilt, stitched together by gravity, quantum fields, and the wild imagination of physicists who stay up way too late doing math. So, could wormholes actually let us visit another universe? Right now, we don't have the tech, the energy, or the understanding. But we do have the equations and the questions. And that's where discovery begins, because the universe, maybe even the multiverse, has never given up its secrets easily. But wormholes? They might just be cracks in the wall, and through those cracks, who knows what wonders or dangers we might glimpse. All right, let's say humanity finally discovers a wormhole, hidden in deep space, stable, and just barely wide enough to send something through. We're not putting an astronaut in there, not yet. That would be insane. So, we do what humans always do when something looks dangerous and fascinating. We send a robot. A small, highly shielded, AI-powered space probe. Let's call it Pathfinder 1. We guide it to the wormhole's edge. It hovers for a moment, collecting data, scanning radiation levels, measuring gravitational distortions. Everything seems calm, eerily calm. Then, on command, the probe inches forward and disappears into the wormhole. And now, we wait. Here's where things get very interesting. From Pathfinder 1's point of view, the trip might take less than a second. But what happens to the data it tries to send back? That depends on the nature of the wormhole. If it leads to another part of our universe, perhaps somewhere in a distant galaxy, radio signals could theoretically still travel back through space. But if the wormhole leads to an area billions of light years away, or worse, to another timeline or universe, receiving data would be a lot trickier. The wormhole might be one way, meaning Pathfinder can go in, but signals can't come out. Or maybe the exit point is moving relative to Earth, and by the time the probe sends its message, we're no longer in the same cosmic neighborhood. Worst case scenario? The wormhole collapses behind it, and we never hear from Pathfinder again. But maybe we do. Let's imagine the probe makes it. It emerges in a distant star system. Its cameras come online. It sees a sky full of unfamiliar constellations, perhaps orbiting a red supergiant or floating near a black hole no Earth telescope has ever detected. It starts beaming images home. And for the first time in history, humanity sees something on a screen that no human has ever seen before, not even through a telescope. We've literally peeked through a hole in space-time and looked out the other side. This changes everything. Instantly, governments, research labs, and even private space companies would scramble to study the wormhole. Some would want to send more probes. Others, well, let's be honest, would want to send people. But here's the real twist. What if Pathfinder saw something? Not just stars and radiation, but a signal, a structure, a shape? What if it detected technology? Now we're not just talking about cosmic travel. We're talking about first contact. See, one possibility physicists have debated for decades is that wormholes might be artificial. Naturally occurring ones would be too unstable to use. But what if a far more advanced civilization learned how to build or anchor one? What if we stumbled across one of their portals? That would mean we're not alone, and that whoever's out there is thousands or millions of years ahead of us. Suddenly, the stakes become astronomical. Would we try to talk to them? Would we dare follow Pathfinder 1 into the unknown? Would they come through? The philosophical, scientific, and ethical questions multiply faster than our equations can keep up. But let's bring it back down to Earth for a moment. Even without aliens, even if Pathfinder just sends back a few blurry photos of strange stars, that alone would redefine what we know about the universe. It would prove wormholes aren't just real, they're navigable. And once something is proven navigable, the dreamers and builders of our species will find a way to follow. Because that's what we do. We see a door in the dark, and we just have to know what's on the other side.